So integration we also call as antiderivative. Okay. So write down this antiderivative is also called integration. Suppose I am giving you an example. I have dy dx of half x square. This is nothing but half into, what is the derivative of x square? 2 into x power 2 minus 1. X power n, what is the derivative of x power n? N into x power n minus 1. Na? This 2 gets cancelled and this is nothing but x. Okay. What is the derivative of x power n? D by dx of x power n. N into x power n minus 1. Okay. So, if I go for this, what is integral x dx? I will get this as x square by 2. Okay. So the reverse process of differentiation is nothing but integration. If you integrate x with respect to dx, you will get this. Understanding? And in general formula, I will be giving you general formula. And the general formula of integral x power n dx is x power n plus 1 by n plus 1. This is the general formula, okay? Here this is integral x power 1 dx. X power 1 dx and x power 1 plus 1 by 1 plus 1. That is x square by 2. Okay, this is the general formula you have to remember. Integral x power n dx. So the previous class you have learned to calculate how we integrate when a graph is given. You have to just find the area under the graph. That is nothing but integration, okay? Integral f of x dx. Okay, we have considered a small element dx, delta x. And we have considered rectangles and we found out the area of all the rectangles. And we have small triangles also there and we have neglected the triangle area if delta x is tending to 0. Okay. Even if the graph is not given, if the function is given, like x power n is a function, okay, then also we can find the derivative integration of that function like this. So this is the first formula which you are seeing. Integral x power n dx is x power n plus 1 by n plus 1. Okay. Now we do you have to note down the other formulas also. This is the first formula. Okay. So antiderivative of this a function is nothing but integration. Okay. So we'll go for other formulas of integration, right? Just I'm erasing this. Okay, the second formula is like this. Integral cos x dx is sin x. Okay. Just you take one more thing here, plus c. Sin x plus c. That c is called constant of integration. What is that c called? Constant of integration. For example, if I have a derivative of dy dx of x square plus 2, this is nothing but 2x plus 0. Derivative of a constant is 0, na? derivative of a constant is 0. If I do the integration of this, integral 2x dx, I am getting 2 into x dx, what is that? X square by 2 na? X power 1 plus 1 by 1 plus 1. So what about this 2? This 2 we are not getting while we are doing integration. So that I will write it as plus c. C is the constant of, here I have written c na, that only. C is the constant of integration. Okay, while doing derivative we know that derivative of a constant is 0. But while doing integration we are not getting that. So we have to write that as some plus c. Okay, we can calculate that c by applying proper limits, by applying the condition. Given conditions apply jaste, we can find out that c value. Are you understanding? So you will learn how to do that. For example, you have charge which is given as 2t plus 2. What is the current after 2 seconds? I will find I is equal to dq by dt. This is nothing but 2. 2t square I will give, 2t square plus 2. What is the derivative of t square? 2t na? 2 into t power 2 minus 1, 2t. Now this is the current which is varying with time. After 2 seconds, what is the current means? T, substitute t is equal to 2 here. Current is nothing but 8 amperes. Okay. So now you have in some problems they will give the current and they will ask the charge. And current, for example, it is 4t and charge is integral I dt. We have to go in the reverse way. Actually, if current is constant, charge is current into time only na. Current constant unte Q ela rastaru. Q is nothing but I into t. If current is not constant, you have to go for integration. You have to write it like this. So this is nothing but integral 4t dt. Okay. So there are many cases where we find if charge is given, we have to find current, then we have to do the derivative. And if current is given and then we have to find charge, you have to go for integration. Current is changing with time. It is not constant. If it is constant, directly charge is nothing but current into time. If current is constant, it is not changing with time. Similarly, we have velocity as dx by dt and displacement as integral v dt. Displacement as integral v dt. Otherwise, if velocity is constant, velocity into time is nothing but displacement. Velocity constant unte, velocity into time displacement and rasecha. If velocity is not constant, then you have to go for integration for calculating displacement. Okay. Here if I do this integration, I will get it as 4 into t square by 2. 2t square I will get. But what about the constant? So that only I will write it as plus c. Okay. 2t square plus c. Everywhere we will be getting that this c can be 0 also. In some instances that c can be equal to 0. Okay. For example, charge is equal to what I am getting is 2t square plus c I am getting. So there will be a condition given in the problem that at time t is equal to 0, charge is 2 coulombs. At time t is equal to 0, a problem, an example. Ikkada t0 పెట్టండి, ఇక్కడ q2 తీసుకోండి, take this q as 2 and c will be equal to 2 na. Like this some condition will be given for the calculation of this c. Otherwise leave it like that, plus c. If limits are given a to b, limits are given, then there is no need of taking this constant of integration. Okay. Because we have to substitute the limits. First upper limit we have to substitute and then lower limit. Okay. We will do some problems. You will understand that. Okay. Next. So I am writing this c. C is nothing but the constant of integration. Upon substituting proper values of x, we can find the value of c. So c value can be found out by the given conditions in the problem. Are you understanding? If a problem is given, some condition will be given for finding out c, or limits will be given, limits. Okay, so time is changing from what 0 to 5 seconds. If limits is given, there is no need of taking plus c. Okay, that plus c and minus c will get cancelled. Okay, if limits are given, we will discuss those problems also. Okay. So next, what is c there? C is the constant of integration. C is the constant of integration. Okay, third formula will go. Third formula, integral sin x dx minus cos x. Fourth one, everywhere that c is constant. You know the derivative of sin x is cos x, yes. And what is the derivative of cos x minus sin x? So what will be the integral of sin x minus cos x? Just the reverse thing. Okay, next fourth formula, sin x cos x secant square x. Secant square x is tan x. Okay, because derivative of tan x is, you are getting bored, huh? Derivative of tan x is secant square x, you know that. But so if we go in the reverse way, integration of secant square x is tan x. Okay, reverse is correct. Okay, antiderivative of this is nothing but this tan. This integration is also called antiderivative because derivative of tan x is secant square x. Okay, next integral cosecant square x dx minus cot x plus c. You know that the derivative of cot x is minus cosecant square x. So if we do that integration of cosecant square x with respect to dx, I have to say like this: integral f of x dx, okay, minus cot x plus c. First you note down these formulas and I will give few more. I can erase that part of the board. So I want to tell you how you can understand this plus c. Plus c is that c is nothing but constant of integration. So if I do the derivative, I am getting 2x. If I do the integration, I should get x square plus 2, na? So but I am only getting x square. So I added another plus c. That is, c is the constant of integration. Okay. Note down up to this. So I can erase that part of the board now. So what is, if you do the derivative of charge with respect to time, what you will be getting? Current. If you do the integration of charge with respect to time, you will get current. Integration of current with respect to time, then you will get charge. Reverse thing is possible. I am just erasing this, right? And I write few more formulas of this integration. Okay, sixth one, integral secant x into tan x. Secant x into tan x dx. Okay, this is nothing but secant x. Okay, plus c. What is c there? C is the constant of integration. Because you know the derivative of secant x is secant x into tan x. So integration of this will be this, antiderivative. Okay. Next, integral of cosecant x into cot x is nothing but minus cosecant x. Is nothing but minus cosecant x plus, what is the c? C is called the constant of integration. Okay. Next, eighth one, 1 by root a square minus x square dx. is this is nothing but 1 by a sine inverse x by a plus c. 1 by a sine inverse x by a plus c. Only in few problems we will be getting this. Okay. Sine inverse, this is also inverse trigonometric function, sine inverse x. Okay. Sine inverse x by a. There is one more formula. Integral 1 by x square, a square plus x square plus a square dx. Okay. This is nothing but 1 by a sine inverse వస్తుందంతే. Sine inverse x by ఇక్కడ వస్తుంది 1 by a. 1 by a tan inverse x by a plus c. Okay. Note down this. X square plus a square. దీనికి రాదు 1 by a, దీనికి వస్తుంది. Total 9 formulas you have. Okay. And if you go to the actual integration in maths, you can have many other, but these formulas are enough for physics. Okay. And I will give one example. And the rules of integration is also there. First we have to go for the rules of integration. Shall I erase this? Okay, Azhar, very good. Okay, Sai Surendra, thank you. Right, I can go for the next board. Next board, and I have to erase this. I cannot keep another board in here. Okay. See, you read the formulas of derivative also, and now you read the formulas of derivative as well as integration, and just the anti-derivative of this function is nothing but it is nothing but integration. Derivative of sin x is cos x. What is the integration of cos x? Sin x plus c. What is that c there? C is the constant of integration. Okay. Next, let us go with few examples. First, rules of integration. You have to write rules of integration. The first one, integral some constant into f of x dx is nothing but c into integral f of x dx. All the constants you can bring out of integration. All the constants you can bring out of integration. So that is the first rule. While multiplying c with a function, this function is depending on x, and that c can be brought out of this integration. Okay. Next, if we have let f of let f of cx is equal to f of x, constant is there inside the function, then integral of f of x dx is nothing but 1 by c into integral f of x dx. F of cx, you can write like this. F of cx into derivative of cx, you have to write like this. F of cx is nothing but capital F of x, na? F of x, okay. It's 1 by c. Actually what we did, d by dx of sine 2x, what is the sine 2x derivative? Cos 2x into 2, na? Cos 2x into 2. So inside function we have to do the derivative and multiply it, and in the integration we have to divide it. That is the difference. For example, I have integral 2 cos 2x dx. 2 I will take outside because this is constant. Okay, what is integral cos 2x? Integral cos 2x is sine 2x divided by 2. Okay, inside function you have to do the derivative and divide it. Okay, this is cancelling. Okay, so is this correct? Derivative of sine 2x is this much, and if I do the integration of this, I have to get this. I am getting this, na? So if you are having a function like this sine 2x, it is not sine x, sine 2x. So that x is multiplied with by some constant. Okay, then first you have to do the integration of outside function. First you have to do the integration of outside function. Okay, and then inside function you have to do the derivative and divide it, and you have to divide that. Okay, so that is the second rule, and the second rule you can take the example like this. This is the example of the second rule. Integration of 2 cos 2x dx. 2 you already have to bring outside because that is constant before the function. Bring out of integration. And what is cos 2x integration? Sin 2x. Sin 2x है cos x की integration है sin x. But sin cos 2x के sin 2x. Inside function is there, that you have to do the derivative. 2x derivative is 2, and that you have to divide. Okay, note down this example for understanding this rule. Next, third rule is there. Integral f of x plus. There are two functions like this. Integral f of x dx plus integral g of x dx. This function you integrate separately, and this function you can integrate separately and then add. Okay, this is the third rule. Okay. Next, one more rule is there that we don't frequently apply, but you need to learn that. Okay. In second year nuclear physics, one part for finding a mean life of a sample, radioactive sample, there we'll be applying this fourth rule of this integration. So I will erase this thing. Fourth rule of the integration, I will write it on the top. So if there are two functions, integral f of x into g of x dx. So you can write it like this: f of x into integral g of x dx minus integral f dash x. F dash means derivative. Okay. F dash x means d by dx of f of x. Okay. So another integration I have to take, g of x dx. So I have to put it like this. So just write down the formula. Later we will be applying, and that only at one time there for finding the mean life of a radioactive sample. We have to apply this formula. Just note down later. You will be learning in maths also, second year maths, this part, integration. Okay. So we will do some examples based on this concept. Okay. అర్థమవుతుందా? అరెస్ట్ చేస్తానే. Already I gave you the example for the second rule. So for the third rule I will give you one example. This example later you can learn. Okay, not very urgently we can learn. Okay, this is a big thing. If I teach you this at this time, you will be a little confused. Okay. But this will not be applying maximum in the first year, only in the second year we will be applying this formula. Product of two functions are there, then how to do the integration. Okay, example is integral 2x square plus 2x plus 4 dx. I will give the limits also. Limits are from 0 to 2. These are the limits. So I need not write plus c. Plus c I need not write. I will just substitute the limits. And first of all, 2 into integral x square dx plus 2 into integral x dx plus 4 into integral dx. Okay, I can write it like this. This integration goes to each individual function. Each individual function, x square it is going, x it is going. Okay, this 1 I can write as x power 0. 1 I can write as x power 0. And what are the limits? 0 to 2. Limits are from 0 to 2. Okay, in the problem, what is the displacement of the vehicle between 2 and 4 seconds? So lower limit is 2, upper limit is 4. Okay, like that. Limits, what is the displacement of the vehicle? And integral v dt you will be doing, and lower limit 2, upper limit 4 you can take. If the question is asked, what is the displacement of the vehicle between 0 and 4 seconds? So lower limit 0, upper limit 4 you can take. Okay, that is the in the problem you can apply the limits. Okay, so this is nothing but 2 into x cube by 3. Integral x power, what is integral x power in dx? Cheppadamma, x power n plus 1 by n plus 1 kada? Is this correct? Okay, and x power 2 plus 1 by 2 plus 1. Okay, next 2 is already taken out. So what is integral x dx? X power 1 plus 1 by 1 plus 1 and x square by 2. Limits is 0 to 2. Here also limits is 0 to 2. 4 into, what is integral x power 0? X power 0 plus 1 by 0 plus 1. What is that? X. And okay, here this formula works only if n is not equal to -1. Okay, I will tell you what if I take n as -1. Okay, this formula will work only if n is not equal to -1. Okay, so first of all, this 3 you can take outside, and first you substitute the upper limit in x, 2 cube minus lower limit, now you can substitute 0 cube. Okay, plus, so we the area of the trapezium we found out na, half into sum of parallel sides into distance between the parallel sides. There we got b square minus a square by 2. Okay, just limits we can substitute the limits, like the first upper limit you can substitute, and lower limit also you can substitute. It 2 could cancel in. Okay, first in the x you substitute the upper limit, 2 square minus 0 square, and here 4 into 2 minus 0 is 2. Okay, and this is 8 into 2, 16 by 3 plus 4 plus 8. Okay, and we have to take the LCM of this. What is the LCM? Here I will do this LCM part. 3 is the LCM. 16 plus 12 plus 24. What is this? 36 plus 16 is how much? 52 by 3 is the answer, okay? 52 by 3. Whatever is the physical quantity, you can have to express it, the units also at the ending. For example, force is changing with displacement like this. Force integral f dx is nothing but work done. You have to take joules here. What are the units of work done? Work done units enti joules kada. And here force is not constant. Otherwise work done is f dot f bar dot s bar. So directly you can multiply. No need of going for integration. If force is changing, then you have to go for integration. Okay. So we can have many examples for integration. If something is not constant, then you have to go for integration. You cannot multiply it directly. Okay. A small element, we take dx element, and for that small element, that function is constant. This function is constant for that small element. That much small element. And then you have to integrate. Okay. Note down this. Over. If n is equal to -1 unte endo chuddam. ఇది చేయగలరు కదా చిన్నవి. x square ఏంటి for integration x cube by 3. Integral x dx x square by 2. Integral 1 dx. Integral 1 dx x అవుతుంది. Because 1 I can take it as x power 0. Okay. X power 0 plus 1 by 0 plus 1. How much is that? X only. Integral 1 dx is x. Okay. I'll just erase this. Okay. So, what is I haven't given that formula. Actually, integral 1 by x dx is log x. I note down that as the 10th formula. 10th formula is integral 1 by x dx is log x. 9 formulas I gave there, no? Because derivative of log x is 1 by x. Okay. Is this over? Let us go for the concept of vectors. Okay. If there is any homework, I'll just keep that homework in your group. Okay. Not many questions because you will be struggling initially. Okay, 5 to 6 questions I will give today. Okay. Then you can also post your doubts in my personal WhatsApp number. Okay. Then I can clarify those either in the class or on a paper, and then take the photo and post it to you. Okay. Whatever the way it is easy and understandable to you, I will approach in that way. I will go in that way. Okay. So shall we go for vectors? So basic mathematics is what we discussed till now. Okay. And we will go for vectors. Okay. So vectors. So all physical quantity. What is a physical quantity actually? Physical quantity. Physical quantity is the one which is measurable. Physical quantity is the one which is measurable. Length of a chalk piece, length of the length of this board. Okay, it is measurable. Okay, which is measurable. Okay, and there are many other things which are not measurable. Okay, that will not come under physics. Okay, for example, now physics and bio Indian, you said that you are afraid of physics, and I cannot bring a meter and measure it how much you are fearing. I cannot bring an instrument. Okay, that fearness is not a physical quantity. Okay, the parents love their respective kids, and we cannot measure that quantity called love is not measurable. Okay, parents love we cannot measure. Okay, so this what is a physical quantity means only in physics we consider only these, not which we cannot measure. That will not come under physics. Okay, I like physics more, one student said. Okay, but I cannot have a thing which can measure that, so that will not come under physics. So physical quantities, so all physical quantities are divided into vectors and scalars. All physical quantities are divided into, first we'll write scalars and vectors. Scalars are those physical quantities which has only magnitude. This has only magnitude. Okay, what is the example? Example is distance is a scalar. Okay, time is a scalar. Okay, even though it goes in a particular direction, you cannot go back in time. No? Maybe it is possible, maybe we don't, but at the present at our conscious mind says only time is going forward. Okay, we cannot go back in time. Our conscious mind is maybe some subconscious mind, maybe some thing is possible that we can go back in time. Okay, but at the present time is going in forward direction. But why we treat it is having a direction, time is having a direction, why we treat time as scalar? Because that need not always be mentioned. The time goes always forward. Okay. In the same way, pressure is there. Pressure is scalar, but pressure is force per unit area. Na? Pressure is force acting per, actually force. Okay. Okay. Pressure is force acting per unit area, but force is vector. Force vector. But why pressure is scalar? What are the units for pressure? Newton per meter square, na? Newton per meter square. Its other name is called Pascal. Newton per meter square is otherwise called as Pascal. This is the name of a scientist. Okay, why we are treating pressure as scalar, even though force is vector? Because if there is a bottle with you, water bottle, okay, when you, and it is useless, you want to throw it, and you have kept a hole, and inside water is there. Water will emerge perpendicular to the surface. That force acts always perpendicular to that given surface. That's why you need not mention that. Always it acts perpendicular. Time is always going forward. No need of mention. Always it is going in forward direction. No need of mentioning that. So here also always that pressure, the force which is giving the pressure, which is applying the pressure, is always perpendicular. We have a gas cylinder in our houses. Inside we have the gas. That gas will be applying pressure on the walls of that cylinder. How it will apply? Perpendicularly it will apply. Okay, so pressure is always a scalar quantity. No need of mentioning the direction. Always it is perpendicular. Okay. Next, current is scalar. Current is scalar. Okay, because it will not obey vector laws of addition. This is important. Okay. What physical quantities are called as vectors means those physical quantities which has some magnitude and direction, and they obey vector laws of addition. The third thing is also should be included. For example, I have a current like this, 3 amperes current, and this is 4 amperes current, and the angle between these two is theta, and in this wire the current will be 7 amperes. So it is not depending on the angle theta. Current is directly getting added up. Simple addition, not vector addition. So vector addition means, for example, if two forces are there in the same direction, then what is the net force F1 plus F2? If two forces are acting in opposite directions, then what is the force acting on the object? F1 minus F2. Okay. If there are two forces acting at certain angle, then resultant force will be root over F1 square plus F2 square plus 2 F1 F2 cos theta. That is parallelogram law of vectors. So that this is not obeying. Current is not obeying that parallelogram law of vectors. Root over I1 square plus I2 square plus 2 root I1 I2 plus 2 I1 I2 cos theta. I am not doing like directly adding. I am directly adding it. So what are vectors? So even current is a scalar. Even though it is having direction, it is a scalar because it is not obeying parallelogram law of vectors. So these has what are vectors? These has both magnitude and direction. Both magnitude and direction. What is the other thing it has to obey? It has to obey vector laws and also obey vector laws of addition. Vector laws of addition. Okay, note down this. PQ means what? Physical quantities. Examples రాద్దాం. First is రాయండి. Okay. I will drink some water in the meanwhile with this copper jar. In my college I cannot bring this. Okay. I think copper water bottles are there in the market. Dr. Copper. So that is what these doctors are now telling these days. Prevention is better than cure. You increase your immunity levels. Generally, young people have more immunity. Okay. But even you have to follow the rules of because you may not get affected. Some old people in the house might get affected. Okay. So this has both magnitude and direction, and they also obey vector laws of addition. Okay. I'll just erase this. Examples I have to give now. What are the examples? Just I will mute. I will take the mute off. 1 minute. Tell the examples. Displacement. Chappan. Displacement is vector. Inka. Force. Force. Momentum. Okay. Momentum is vector. Etc. There are many quantities. Even in electricity, second year part, you will get other physical quantities. There also we will understand what is this vector quantity, what is the scalar quantity associated in that electrostatics. There are many physical quantities. Okay, I have written only few, but these are important because sometimes you take current as vector, but current is not vector. Current is scalar because it will not obey parallelogram, this vector's laws of addition. Directly we are adding, no need of seeing direction. And even time, pressure is also scalar. Okay, I am just erasing this, right? And so we'll concentrate on vectors, vector addition. Scalars are added directly. Okay. If some in some way you went to a market and your father also went to the market, he brought 1 kg sugar and you also brought 1 kg sugar, but there is a war in the house. Who asked you to bring? So actually 1 kg of sugar is needed in the house, right? So that is not the question here. What is the total amount of sugar means 2 kgs. We need not see the direction. Okay. రైట్. అంటే ఇంట్లో పంపించారనమాట. అంటే ఫాదర్ మర్చిపోతారని మీకు చెప్పుంటారు. ఇద్దరు తెచ్చేస్తే ఇప్పుడు ఎక్కువైపోతుంది కదా. అంటే షుగర్ అయితే ఇట్ ఈస్ వీ కెన్ స్టోర్ ఇట్. If some vegetable like thing we cannot store it and right. Mass is weight is vector, weight is mg. It is vector. Weight is having direction downwards. And now any vector is represented by an arrow. The length of the arrow tells its magnitude. And this is direction. We can see the arrow head. Okay, this is called the head of the vector, and this is called the tail of the vector. Okay, if I have another vector like this, certainly the magnitude of these two vectors, the magnitude of this vector is larger than this vector. So the length of the vector, the length of the arrow gives us the magnitude of the vector. Okay, and direction is what we are seeing at the head. Okay, and if we are having two vectors and we need to find the angle between two vectors, so this angle between two vectors. Okay, suppose I take these two vectors. This is one vector a bar and this is vector b bar, and I have to see that this is a bar and this is b bar, and this is theta. Theta is the angle between the two vectors. And the smallest angle chudali. You should not take the largest angle. Okay, not this angle. Like this smallest angle between the two vectors is the angle between two vectors. Okay, and the initial point of two vectors should touch, or the final point of two vectors touch. Initial point are coinciding, na? You should not say, for example, a student drawn the thing like this. So this is a bar and this is b bar. Is this the angle between two vectors? No, this is not the angle. So this is wrong, okay? So either initial point of both the vectors should touch or final point of both the vectors. For example, final points are touching. This is like this, and another vector b bar is like this. This is correct. Angle between two vectors. This is correct, okay? Angle between two. This is also correct. And this convention is wrong. And even this, what is the angle between two vectors? The smallest angle only. This another angle is there here behind. For example, if this is 60, this, what is the remaining thing? 360 minus 60, 300 degrees. We should not tell 300 degrees is the angle between two vectors. Okay, 60 is the angle between the smallest angle only we have to consider. Okay. Angle between two vectors, you put the side heading and draw the two vectors from the same initial point. Draw the two vectors from a point so that their tails are coinciding or their heads are coinciding. Okay, draw the two vectors from a common point, so that their tails are coinciding. Initial point of the vector also you can tell, so that the initial point of both the vectors are coinciding. Tails are coinciding or their heads are coinciding. And what is the angle between two vectors? And the angle between two vectors is the smallest angle between two vectors, and the angle between two vectors is the smallest angle between them. This is alpha, the wrong, this is wrong. This is wrong convention. Okay, the final point of the first vector, the second vector is touching. Okay, this is not the angle between two vectors. Initial point of the second vector is touching. This is not the angle between two vectors. Wrong convention. Okay, note down this. Next we have kinds of vectors. Just erasing this. Either the heads should touch or the tail should touch, and you have to go for the smallest angle. So kinds of vectors, let us go for the different kinds of vectors. Okay. Today we will see only two kinds of vectors. Tomorrow we will go for the remaining kinds. Okay, kinds of vectors. First one is unit vectors. Unit vectors. These are the vectors whose magnitude is 1 Newton of force. So these vectors has magnitude of unity under 1, okay? And these vectors, and if there is a vector a bar, I want the unit vector in this direction, then what I will do is a cap is equal to a bar by modulus of a bar. So whenever you want the unit vector in a direction, in a particular direction of a vector, then you take that vector and divide its magnitude. Okay, then you will get the unit vector. Unit vector is vector divided by its magnitude. Okay. Right. Next, null vector or zero vector. Null vector. Null vector is the magnitude of this vector is 0. The magnitude of this vector is 0. Suppose there are more than one forces acting on a body, and the body is still in equilibrium. Then we say resultant force acting on that body is 0. So force is a vector quantity, but their magnitude of force is 0. then it is becoming a null vector. Okay, and then its magnitude is 0. The magnitude of those vectors is 0, and that is called a null vector. Okay, because there are many kinds of vectors, like vectors, unlike vectors, coplanar vectors. All the vectors lying in one plane, they are called coplanar vectors. Co-initial vectors ante their initial point is same. Okay, and equal vectors ante direction same, magnitude is also same. Unlike unequal vectors ante this like this we have to draw. Okay, just negative vector. This is the negative vector. So tomorrow we'll discuss all those things. Okay, and still we have 5 minutes time, but okay, these are the starting classes for you. You should get accustomed for my way of teaching. Okay, might be it is a different. Everybody teaches differently, na? Okay, you have to get accustomed. It will take time. Okay, bye. Take care. Bye, Azharuddin. Bye.